Okay, let's give you guys some practice. So come up with a Cartesian equation from these parametric equations from negative pi over 2 to positive pi over 2. And this is here just to help you. So press pause and have a go. Okay, so to do this, we ultimately want to eliminate the t. So try to aim towards this. Sine squared t plus cos squared t. So try to aim towards this, because by using this we can eliminate the t. But the thing is, we need to break up this double angle here. We can obtain sine squared easily from this. Square both sides, that will then give you this. But here you've got a double angle here. So use so here you've got a double angle. So either use this, or this. Let's use this one here. So we can break this up by using this. So that will then take us to this stage. That will then take us to here. Okay. So now looking at this, if you look at this sine squared of t, well, you can obtain sine squared of t. You can rewrite this block here in terms of x. So from here, square both sides. That will then give you this. So we can then put the x squared into here. So that will then, this thing here will then become this. Okay, and then rearrange it. Add this block to both sides. That will then give you this. Now we've got cos squared, and then we've also got x sine squared. So remember, we will then use this. So we can put this into the cos squared, and for the sine squared we can put x squared into the sine squared here. So that will then give us this. That will then give us this. So tidy this up, and then that will give us this. If you don't recognize this, then make y the subject. So y equals 1 minus 2x squared. Now this is something that you should recognize. We've done well. If you sketch this, the intercept will be 1. The intercept will be 1, and it wants to do a negative quadratic. So it's going to be something like this. Okay. So now looking back at the original statement. Remember, our graph is something like this. Intercept of 1. It wants to do a negative quadratic. So we need to know the starting point. So refer back to the original question. It's saying t from negative pi over 2 to positive pi over 2. So let's try and identify our starting point. So starting point would be from negative pi over 2. So put it into here. So that would be sine negative pi over 2. Well, sine looks like this, being 2 pi here. This is being pi. Let's extend this into the negative realm. So this is pi. Pi over 2 is right here. Negative pi over 2 is right here. So sine negative pi over 2 will be negative 1. So this thing here, when time equals negative pi over 2, x will be negative 1. So x will be negative 1 somewhere along here. We don't know what this scale is. It's going to be negative 1 somewhere. Okay, so let's just bear that in mind. Now we've got to identify the y coordinate at time equals negative pi over 2. So put this into here. So 2 times this whole thing here, that will then give you negative pi, and then cosine of x looks like this, cos of x looks like that, but we're after negative pi. So this is 2 pi, this is pi. So hang on. So negative pi would be here. So this here would be negative 1. So when time equals negative pi over 2, y will be negative 1. So the starting position, the start time when t equals 1, the coordinates will be negative 1 comma negative 1. Okay, and then now do the same thing for this. So sine of pi over 2. So sine of positive pi over 2. So that will be 1. Okay, so at time pi over 2, x will be positive 1. And then now put this into here. So 2 times this thing here will then give you pi. So cos of pi looks cos of pi is here. So that will be negative 1. So y will be negative 1. So when time equals pi over 2, the coordinates will be 1, comma, negative 1. So 1, comma, negative 1. That will be somewhere here. Okay, so this is when time, oops, I made a mistake here. When time equals negative pi over 2, and this thing here will be when time equals positive. So really, you can see that it's traveling in this direction. Okay.